Hello students, welcome to this lecture 1 quadratic equation. So in this lecture we will start the topic quadratic equation. Okay, so let's get started. So in chapter 2 you have studied different types of polynomials. One type was quadratic polynomial. Okay, there you have studied about linear polynomials, quadratic polynomials and cubic polynomials. And the quadratic polynomials was the one type of the form ax square plus bx plus c, where a does not equal to 0. When we equate this polynomial to 0, we get a quadratic equation. Okay, so what is the quadratic equation? So quadratic equation is basically the equation which actually, when we equate quadratic polynomial equal to 0, then we get this equation. Okay, so you have already have studied about quadratic polynomial. Okay, and you have studied the zeros of a quadratic polynomial. So for finding the zeros of the quadratic polynomial, that case we equate the quadratic polynomial to 0, and we, after solving the equation, we get the values of x. Okay, and that are called the zeros of the quadratic polynomial. Okay, and we have studied there a quadratic polynomial can have at most 2 zeros. Okay, so quadratic polynomial, for a quadratic polynomial, there is either two solutions or one solution, an equal solution, okay, and no solution. Okay, so for quadratic polynomial it does not necessarily have a solution. Sometimes the quadratic polynomial cannot have a solution. Okay, so a quadratic polynomial can be expressed as ax square plus bx plus c, where a does not equal to 0. Okay, and this form is basically the general form of the quadratic polynomial. Okay, and when we equate this quadratic polynomial to 0, then we basically get a quadratic equation. Okay, that is basically when ax square plus bx plus c, this is equal to 0, and this equation is basically called quadratic equation. Okay, so quadratic equations come up when we deal with many real life situations. So there are many real life situations where we face quadratic equations. Okay, so now question maybe come in your mind, why actually we actually study quadratic equations. So basically when we deal with many real life situations, that case the quadratic equations come up. That is why we have to study quadratic equations. Okay, and quadratic equation, this chapter is very important chapters for your board exam. Okay, so very carefully study this quadratic equation chapter, and this chapter here basically will introduce quadratic equations and how to solve quadratic equation, that will learn. Okay, and in your previous in your earlier classes, in your higher classes, we will study about quadratic equations in details. Okay, so now let's get start by taking an important real life examples. Why we actually how actually quadratic equations come up, that we'll discuss by this example. Okay, so for instance, suppose a charity trust decides to build a prayer hall having a carpet area of 300 square meters with its length 1 meter more than twice its breadth. Okay, so here basically a charity trust decide to build a prayer wall. Okay, decide to build a prayer wall which having a carpet area 300 square meters. Okay, that is this if you think by this figure, so here you can think this is the carpet area, this is the carpet area of this prayer wall. Okay, and this carpet area is basically 300 square meter, and here this side is length of this carpet area. Okay, length of this wall, and this side is basically breadth of this wall. Okay, so now we can consider breadth of this rectangular wall and the length of this rectangular wall. Okay, so what should be the length and breadth of the wall that we have to find here. So suppose the breadth of the wall is x meters. Okay, so here we suppose the breadth of the wall is x meters, then its length should be 2 times x plus 1. 2 times x plus 1, since its length 1 meter more than twice its breadth. Okay, and here its breadth is x meter, so therefore the length of this wall is equal to 2x plus 1 meters. Okay, now we know the area of a rectangular figure. So if we have a rectangular figure like this, then the area of this figure is basically equal to length times breadth. Okay, so here the length is 2x plus 1 meters and the breadth is x meters. Okay, so now the area for this wall is equal to 2x plus 1 times x. Okay, and we have given it having the fair hall having a carpet area 300 square meters. Okay, so now for this information we can construct an equation. Okay, that is actually 2x plus 1 times x is equal to 300. Okay, so 2x plus 1 times x, this is equal to 300, that is given in question. Now if we simplifying this equation, actually here if we multiplying x with 2x plus 1, then we'll get 2x square plus x. Okay, and this is equal to 300. So therefore if we now rearrange this equation, then we will get 2x square plus x minus 300 is equal to 0. Okay, so you get this equation 2x square plus x minus 300 equal to 0. So in left hand side you can easily identify that in left hand side this expression 2x square minus x minus 300 basically are expression for a quadratic polynomial. Okay, that you have studied in your chapter 2, polynomials chapter. Okay, so this expression 2x square plus x minus 300 is a quadratic polynomial, and we know if we have a quadratic polynomial ax square plus bx plus c where a does not equal to 0, and if we equate it to 0, then we get a quadratic equation. Okay, so here 2x square plus x minus 300, this is a quadratic polynomial and this is equal to 0. Okay, so now this is a quadratic equation, 2x square plus x minus 300 equal to 0. This is basically the quadratic equation. Okay, so the breadth of the wall should satisfy the equation 2x square plus x minus 300 equal to 0, which is a required quadratic equation. Okay, so now we'll discuss Sythaacharya formula. So you already have known about Sythaacharya, who was a great mathematician. Okay, so Sythaacharya in CE 1025 derived a formula now known as the quadratic formula. Okay, and that is very helpful formula for solving a quadratic equation by the method of the completing the square. Okay, so Sythaacharya formula or quadratic formula is a very important formula for solving a quadratic equation. Okay, that will help you to find the roots of the quadratic equation. So what is roots of the quadratic equation, that we will learn in our earlier section. Okay, so in this chapter you will study quadratic equations and various ways of finding their roots. You will also see some application of quadratic equation in daily life situations. Okay, so motive of this chapter basically we will learn quadratic equation, about quadratic equation. Okay, and various types of various types of methods of finding their roots. Okay, and third we'll learn. We will also see some application of quadratic equation in daily life situation. Okay, so a quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a does not equal to 0. Okay, so we already have studied about this equation ax square plus bx plus c is equal to 0. That is known as a quadratic equation. Okay, and here for quadratic equations, the coefficient of x square must be non-zero. Otherwise, this equation will not be a quadratic equation. Okay, so for being a quadratic equation, the coefficient of x square must be non-zero. Okay, this must be kept on your mind. So for example, if we take this on 2x square plus x minus 300, this is equal to 0. So this is a quadratic equation. Okay, since here in left hand side, this is a quadratic polynomial and this is equal to 0. And we know when a quadratic polynomial equate to 0, then we get a quadratic equation. Okay, so this is a example of quadratic equation. Similarly, you can take 2x square minus 3x plus 1, this is equal to 0. Okay, this is also a quadratic equation. Okay, and you can take 4x minus 3x square plus 2 is equal to 0. This is also a quadratic equation. 1 minus x square plus 300 equal to 0. This is also a quadratic equations. So these are some examples of quadratic equations. Okay, so in fact, any equation of the form p of x is equal to ax square plus bx plus c is equal to 0, where p of x is a polynomial of degree 2 is a quadratic equation. Okay, so now you from now you can remember this. Any equation of the form p of x is equal to 0, where p of x is a polynomial of degree 2 is a quadratic equation. Okay, so now, but when we write the terms p of x in descending order of their degrees, then we get standard form of the equation. Okay, so maybe you have given this type of quadratic equations like 1 plus 2x plus x square. Okay, so this is equal to 0. So this is also a quadratic equations. Here we can rearrange the terms of this equation. Okay, so then we get the standard form of the equation, that is ax square plus bx plus c is equal to 0, where a does not equal to 0. And here ax square plus bx plus c, where c is equal to 0, where a does not equal to 0, is called the standard form of a quadratic equation. So must be kept on your mind. Ax square plus bx plus c is equal to 0, where a does not equal to 0, is called the standard form of a quadratic equation. Okay, so quadratic equation arise in several situations in the world around us and in different fields of mathematics. Okay, so quadratic equations are very important for your mathematics subject. Okay, also for any other subject like physics, chemistry, economics, that case we will also use the quadratic equations. Okay, so there are so many applications, there are so many real life applications of a quadratic equation. Okay, so now let us consider a few examples. So now we'll explore some examples one quadratic equation. So in first example, here we have to represent the following situation mathematically. Okay, so here we have given one question 1. It said John and Jivanti together have 45 marbles and both of them lost 5 marbles each, and the product of the number of marbles they now have is 124. We would like to find out how many marbles they had to start. Okay, so this mathematical this situation basically we have to represent in mathematically. Okay, so here we'll see how can we how can we represent the situations in mathematically. So here we let the number of marbles John had be x. So John had be x marbles, and then the number of marbles Jivanti had 45 minus x, since they had total marbles 45. Okay, so number of marbles Jivanti had 45 minus x. Okay, so the number of marbles left with John when lost 5 marbles, that is x minus 5. Okay, so the number of marbles left with John when the lost 5 marbles is equal to x minus 5. Okay, and the number of marbles left with Jivanti when she lost 5 marbles, that is equal to 45 minus x minus 5, and this is equal to 40 minus x. Okay, so this is equal to 40 minus x. So therefore their product x minus 5 into 40 minus x. Okay, so their product is x minus 5 times 40 minus x. So now if we use this formula, like x minus a times a minus x, b minus x. Okay, so if we now product this to this, this to this, and this to this, and this to this. Okay, so basically if we product these two factors, then we will get this is equal to 40x minus x square minus 200 plus 5x. Okay, and now if we simplify this expression, then this will give us this is equal to minus x square plus 45x minus 200. Okay, so the number of marbles left with John and Jivanti when they had lost 5 marbles, okay, that are x minus 5 and 40 minus x, and the product of their marbles when they lost 5 marbles is equal to x minus 5 times 40 minus x. Okay, and if we simplify this, then we'll get this is equal to minus x square plus 45x minus 200. Okay, and we have given in question when they lost 5 marbles each, then their number of marbles, product of their number of marbles, this is equal to 124. Okay, so this expression minus x square plus 45x minus 200, this is equal to basically 124, where given that product is equal to 124. Okay, so now if we simplify this equation, then we will get minus x square plus 45x minus 324 is equal to 0. Okay, now if we change the sign of some sign by common out minus, okay, and then we'll get this equation x square minus 45x plus 324 is equal to 0. So this is the mathematical representation of the given situations. Okay, so now we will represent this given situation in question number 2 in mathematically. Okay, so here it said a cottage industry produces a certain number of toys in a day. The cost of production of each toy in rupees was found to be 55 minus the number of toys produced in a day. Okay, so on a particular day, the total cost of production was 750 rupees. Okay, we would like to find out the number of toys produced on that day. Okay, so we would like to find out the number of toys produced on that day. Okay, so basically we have given this information, the cost of the production of each toy was found to be 55 minus the number of toys produced in a day. Okay, and on a particular day, the total cost of production was 750 rupees. Okay, so now here we'll solve this problem. Okay, so if we can first let the number of toys produced on that day be x. Okay, and therefore the cost of production in rupees of each toy that day, this is equal to 55 minus x. So the total cost of production in rupees that day is equal to x times 55 minus x. Okay, and we have given the total production, the total cost of production one that day is equal to 750 rupees. Okay, and in terms of x, we have here the total cost of production in rupees that day is equal to x times 55 minus x. Okay, so now we get this equation, x times 55 minus x, this is equal to 750. Okay, so now if we simplifying by taking product of x times 55 minus x, that is equal to 55x minus x square, this is equal to 750. Okay, so now if we write this equation in ascending order, descending order, okay, then we get this equation minus x square plus 55x plus minus 750 is equal to 0. Okay, and if we now rearrange this equation, then we get this equation x square minus 55x plus 750 is equal to 0. Okay, so we get this quadratic equation, x square minus 55x plus 750 is equal to 0. Okay, so therefore the number of toys produced that day satisfies the quadratic equation x square minus 55x plus 750 is equal to 0. Okay, which is the required representation of the problem mathematically. Okay, so here basically we represented the given information, given situations of the problem mathematically. Okay, so here we did not solve the quadratic equation. Okay, so we'll basically solve this quadratic equation in our earlier section. Okay, so there we'll see some methods how to solve quadratic equations. Okay, so there basically we'll learn two methods. First method is how to solve by factorize quadratic polynomial. Okay, so we know how to factorize quadratic polynomial by splitting middle terms. Okay, that we can use that method and we can find solutions of that quadratic equation. Okay, and the second method is by using quadratic formula, that is SATHEE-ENGG formula. By using SATHEE-ENGG formula, we can find the solutions of the quadratic equation. Okay, so in this example basically we represent the situations that was given in words, we represent them in mathematically. Okay, so in next examples, here we have to check whether the following are quadratic equations or not. Okay, so we know how can we check an equation which is a quadratic equations or not. Okay, so in first one, here we have given x minus 2 whole square plus 1, this is equal to 2x minus 3. Okay, so if we see solution, here in left hand side we have given x minus 2 whole square plus 1, and now if we use the identity a minus b whole square, that is equal to a square minus 2ab plus b square. Okay, so if we use that identity, then we'll get this is equal to x square minus 4x plus 4 plus 1. Okay, and this is equal to x square minus 4x plus 5. So we get this expression, that is a quadratic polynomial. Okay, so therefore x minus 2 whole square plus 1, this is equal to 2x minus 3, and we can be rewritten as x square minus 4x plus 5, this is equal to 2x minus 3. Okay, and now if we simplify this, then we'll get this equation x square minus 6x plus 8 is equal to 0, and it is of the form ax square plus bx plus c is equal to 0. Okay, so therefore the given equation is a quadratic equation. Okay, so now let us see next one. So in next one we have given this equation x times x plus 1 plus 8, this is equal to x plus 2 times x minus 2. Okay, so now if we simplify this equation, then we can get an equation, and then we can check whether this equation is in the form of ax square plus bx plus c equal to 0. Okay, so let us see the solution. So here, since x times x plus 1 plus 8, this is equal to x square plus x plus 8. Okay, and in right hand side we have x plus 2 times x minus 2. This is equal to x square minus 4. Since we know the identity a plus b times a minus b, this is equal to a square minus b square. Okay, so x plus 2 times x minus 2, this is equal to x square minus 4. And now if we equate left hand side and right hand side, then we'll get x square plus x plus 8 is equal to x square minus 4. That is x plus 12, this is equal to 0. Okay, so x plus 12, this is equal to 0, and this equation basically is a linear equation. Since in left hand side we have given x plus 12, and this is basically a linear polynomial. Okay, and if we equate to 0, then we get a linear equation. Okay, so this is not of the form ax square plus bx plus c is equal to 0. Okay, so therefore the given equation is not a quadratic equation. So in two above, the given equations appears to be a quadratic equation, but it is not, appears to be a linear equations, but it is not a quadratic equation. Okay, so this is appears as a linear equation, but it is not a quadratic equation. Now let us see number 3. So in question number 3 we have given x times 2x plus 3, this is equal to x square plus 1. Okay, so now we can solve by taking left hand side. This is equal to x times 2x plus 3, and this is equal to 2x square plus 3x. Okay, and so x times 2x plus 3, this is equal to x square plus 1, can be rewritten as 2x square plus 3x is equal to x square plus 1, and therefore we get the equation x square plus 3x minus 1, this is equal to 0, and it is of the form ax square plus bx plus c is equal to 0. Okay, so the given equation is a quadratic equation. Okay, so the given equation is a quadratic equation. Now let us see question number 4. So in question number 4 we have given x plus 2 whole cube, this is equal to x cube minus 4. Okay, we have given this. So now we can solve by taking left hand side. This is equal to x plus 2 whole cube, this is equal to x cube plus 6x square plus 12x plus 8. Okay, so basically here we use the identity a plus b whole cube, that is equal to a cube plus 3a square b plus 3ab square plus a plus b cube. Okay, so if you use that identity, then we get the value of x plus 2 whole cube, that is equal to x cube plus 6x square plus 12x plus 8. So therefore x plus 2 whole cube, this is equal to x cube minus 4. So can be rewritten as x cube plus 6x square plus 12x plus 8 is equal to x cube minus 4. That is 6x square plus 12x plus 12 is equal to 0. Okay, or if we can simplify further, then we'll get x square plus 2x plus 2 is equal to 0. Okay, so this equation in equation 4, the given equation appears to be a cubic equation and not a quadratic equation, but it turns out to be a quadratic equation by simplifying. Okay, so as you can see, often we need to simplify the given equation before deciding whether it is quadratic or not. Okay, so here basically we have to simplify the given equation. Okay, if we get this is of the form ax square plus bx plus c is equal to 0, then the given equation is a quadratic equation. Okay, so here we get, after simplifying the equation in 4, we get the equation which is of the form ax square plus bx plus c is equal to 0. So the given equation in 4 is a quadratic equation. Okay, I stop here this lecture. Thank you very much to all of you.